Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. This is the fourth video guys of me tackling the Johannesburg Central District March Control Test. This test was written in the year 2024. It's the first test that you write as a grade 12 learner. Please guys do take it serious because it will contribute a lot in your final exam. Okay, since I'm doing the fourth video rather, it simply means that I've answered the first three questions in three separate videos. Each and every question has its own video. And please note that the last two videos will be uploaded after this one. Just make sure that you click the link on the description below. It will direct you straight to the playlist with the full memorandum. You can answer the questions with me. And obviously, if there are things you don't understand, please do ask on the comment section. I will definitely come and assist you. And before we start, guys, please don't forget to share the video to your peers. Help them prepare for the test. Don't forget to like, comment if there are things you're not sure about, and most importantly, don't forget to subscribe. Okay, question 4. I'm told that the graph of f of x and the g of x are sketched below. Okay, the graph of f of x is the parabola, and the graph of g of x is a straight line. And then I'm also told that the x-intercept of f are 1 and 3 as shown in the sketch below, and the y-intercept of f of x is here. Okay, and then I'm told that d is the turning point. D is the turning point of the graph of f, and then the x-intercept for g of x is at -8, or rather at point r. And then we are told that both the graphs of f and g intersect one another at k, and the y-intercept as well. Okay, the first thing they want us to do is to determine the equation of f of x in this form. Okay, since we are given the x-intercept, guys, we will find our equation of the graph by saying y is equal to a x minus m and x minus n, whereby both m and n represents my x-intercept. Are you together? So I'll simply have y is equal to a, I'll have x minus 1, and then x minus 3. Are you together? Then the only thing I'm left with is to find the value of a. How can I find the value of a? By just substituting any point on the curve of f of x. I do have a point on the curve of f of x, which is the y-intercept. So I'll simply substitute, because I know that y is equals to 4 whenever x is equals to 0. Y is 4 whenever x is equals to 0. Are we together? And then all I have to do now is to just solve for a. On the left hand side I'll have 4, and then on the right hand side I'll simply have 3a. I'll divide both sides by 3. I'll simply have a is equals to 4 over 3. So therefore the equation of the graph is y is equals to a, that's 4 over 3. Remember that I only wanted to find the value of a here. Are you together? And then I'll simply have x minus 1 and x minus 3. All I have to do is to multiply out the brackets. Still have 4 over 3 there in front, and then I'll have x squared. I'll also have negative 4x plus 3. So therefore the equation will be 4 over 3x squared minus 16 over 3x plus 4. So this is the equation of the curve of f of x in the form of ax squared plus bx plus c. That's y is equals to 4 over 3x squared minus 16 over 3x plus 4. Okay. Second question. Let me create the room for me to write. In the meantime, guys, I hope you are subscribing as I'm creating some room for me to write now. Okay, I'm asked to determine the coordinates of D. D is the turning point of the graph of f, right? I can simply find the x value of the x value at the turning point, and then go and substitute the x value to go and find the corresponding y value. How can I find the x value turning point? I know that the x value turning point is simply negative b all over 2a, right? The value of b is simply equals to negative 16 over 3, and the value of a is just 4 over 3. Whenever I just substitute here, I'll have a negative b is 16 over 3, and then I'll have 2a. The value of a is 4 over 3. Okay, so I know that the x value at the turning point, or rather the x value at d, the x value at d is just equals to 2, né? But there is another way, guys, to find the x value at the turning point. Since I do know the x-intercept, I could have simply said that the x value at d, which is my turning point, I'll just find the average of the x-intercept. The x-intercept is 1, another one is equals to 3. I'll just divide by 2. We'll simply get 2, né? Just to avoid doing all this, you would have just done that. Okay, after finding the x value, guys, your duty is to go and find the corresponding y value. How can you find the corresponding y value? You must substitute the x value in the equation of f of x. You'll therefore find the corresponding y value. All right, together. Remember that f of x is equals to 4 over 3x squared minus 16 over 3x plus 4. I want to find f of 2, the value of y when x is 2. The value of y when x is 2. I'll just punch my precious calculator there. I have 4 over 3, and then whenever I come across x, I'll just substitute a 2 minus 16 over 3 and multiply by 2 plus 4. So the corresponding y value is just negative 4 over 3. So I know that the coordinates of d, which is my turning point, that's positive 2 and negative 4 over 3. Okay. That they want me to find the equation of g of x, né? For me to find the equation of a straight line, guys, né, I need to know the value of the gradient and just any point on the graph. All right, together. How can I find the gradient? I have 2 points on the graph of g that I can use to find my gradient, right? The gradient, let's call this point P, the y-intercept, né? The gradient of line PR is simply y2 minus y1 over x2 minus x1, right? I'll take the y value at P, which is my y-intercept, minus the y value at R, all over the x value at P minus the x value at R. I'll simply get a half. After finding the gradient, I'll simply substitute in the equation that says y minus y1 is equals to mx minus x1. y1 and x1 represent any point on the curve, or rather on the line RP, and m represents the gradient of the line, right? So I'll just substitute. I'll take any point. I can take this one. I'll have y minus a negative 8. That's my x1. My gradient is equals to a half, and then no, I made a mistake here, né? Y1 is 0, but x1 is just negative 8. So I'll simply have y is equals to 1 over 2. Inside the brackets, I'll have x plus 8. This will give me 1 over 2 x plus 4 whenever I multiply insides by the half. Another way, guys, I could have done this the easier way, because I already know my y-intercept, right? Remember that the equation of a straight line has to always be in the form of mx plus c, where the value of c is the y-intercept. So instead of writing c, I could have just written 4 over there. And then for me to find the value of m, I can just substitute any point on the line. I do have the coordinates of r. I know that y is 0 whenever x is a negative 8. The only thing I need to do is to solve for m and then substitute it back here. Okay, I'll take the 4 to the other side. It will be negative 4, and then I'll have negative 8m over here. Divide both sides by negative 8. Therefore, m is equals to a half. Now I do know the value of m. I'll say therefore y is equals to 1 over 2x plus 4. This is the quicker way you could have found the equation of a line. Yeah? So the equation of g simply says 1 over 2x plus 4. Okay. Then question number 4. They want me to determine the coordinates of k. Remember that k is the point of intersection between the two graphs. For the point of intersection, guys, I don't care what kind of a function you are dealing with, whether you are dealing with trigonometric functions, hyperbola, or whatsoever. For the point of intersection, you must always equate the two graphs. I'll say I want the values of x where f of x is equals to g of x, right? Remember that f of x is equals to 4 over 3 x squared minus 16 over 3 x plus 4. This would be equal to, let me write g of x in red, 1 over 2x plus 4, right? Okay, I'm solving x now. And when I'm solving x, I don't want to have fractions. So I can just multiply each and every term by the lowest common denominator. The denominator that I have are 2 and 3. Né? So the lowest common multiples between 2 and 3, that's 6. So which simply means that the LCD will be 6. I'll just multiply every term by 6 for me to remove the fractions. Whenever I multiply the first term by 6, I'll simply get 8 x squared. Whenever I multiply the second term by 6, I'll simply get negative 32 x. And then whenever I multiply 4 by 6, I'll get 24. And then here I'll simply get 3x plus 24. Then now I must take everything to be on one side, because I no longer have fractions, right? I'll simply have 8x squared minus 35x minus 35x, yes, is equals to 0. I can take out common factor there. I have x. I'll be left with 8x minus 35. So which simply means that x can be 0, or 8x is equals to 35. Then x is just 35 over 8. Yes, I was expecting to find one of the solutions to be 0. Why? Because I know that the two graphs will intersect one another rather whenever x is 0. Are you together? So it simply means that this other x value is the x value at point K. So how can I find the corresponding y value? I can just substitute the x value in either one of the two graphs, either the graph of G or the graph of F. But it will be simple for me if I substitute on the graph of G. So I'll simply say G of 35 over 8, this will simply give me 1 over 2 times 35 over 8 plus 4. Let me just punch my calculator. 1 over 2 35 over 8 and then plus 4. This gives me 99 over 16. So the coordinates of k, I'll simply have 35 over 8, and the corresponding y value is just 99 over 16. Okay, so now they want me to find the values of k for which, not k rather, but the values of x for which the graph of f of x is less than 0. My graph will be less than 0 if and only if the graph is below the y-axis. No, rather the x-axis. Ne? Why? Because I know that, remember that, guys, y represents the curve. So when y is positive, the curve is also positive. When y is negative, the curve is also negative. Are we together? So whenever the graph is below the x-axis, I know for a fact that y is negative. That means my graph will also be negative. Are we together? So the graph is just below the x-axis when x is between 1 and 3. So in this region over here, it simply means that my graph is negative. Are we together? So this statement is true if and only if x is between 1 and 3. Okay, and then for the second part of the question, they want me to write down the values of x for which the product of f and g will be greater or equal to 0. Okay, I'm multiplying two things, guys, and I find a positive answer. It simply means that the things that I'm multiplying have the same sign. It's either they are both positive or they are both negative. Are you together? But since you're dealing with graphs, I just want to find out that in which domain do I have both of my graph either above the x-axis or below the x-axis at the same time. Are you together? Okay. If I scan going from left to right, I can see that okay, let me reference with the x-intercept, because I know that after the x-intercept, either the graph will be above the x-axis or below. Okay, this will be A, B, C, and then D. Okay, in position A, that means when x is less than -8, the parabola will always be above the x-axis. However, the straightened graph is below the x-axis. So I am not looking in this region because my graphs are not having the same signs. Are you together? One of them is above the x-axis and the other is below. I want to have them in the same position. Are we together? Whether both of them are above the x-axis or both of them are below the x-axis, right? Okay, and then when I check in space B, both of my graphs are above the x-axis. Are we together? When x is between -8 and 1, both of my graphs are above the x-axis. So that means they have the same signs. They are positive. So I will take this one. However, in space C, between 1 and 3, the graph of f of x is below the x-axis and the graph of g of x is above the x-axis. So I'm not looking here in this space. But when I go to D, when x is greater than 3, I can see that both of my graphs are above the x-axis. So that means both of them have the same sign. So for me to write the answer here, I'll simply say the statement is true when x is between -8 and 0, or when x is just greater or equals to 3. That's how I could have interpreted these two questions. Excuse me. Okay, now let's do the last one. We are told that when the graph of f is shifted 3 units down and 2 units to the right, it forms the graph of h of x. Write down the equation of h in the form of in that form over here, né? Okay, remember that the graph of f of x, is simply equals to the value of a we got 4 over 3, right? And then the x value at turning point we got a positive 2, so I'm going to write negative 2 there. And then the y value at the turning point was negative 4 over 3, so I'll write it as it is. So I'm being told that for me to obtain the graph of h, some transformations were made to the graph of f. The first transformation that was made was that the graph of f was shifted 3 units down and 2 units to the right. Okay, so basically they're telling me that for me to get the graph of h of x, I need to take f of x and move it 2 units to the right and then 3 units down. Are you together? F of x, I know that f of x is equals to this, right? So whenever I come across f of x, whenever I see x, I'll just substitute x minus 2. But remember that inside the bracket of f of x, there is a minus 2 over there. So I'll just write it like this. And then there's a negative 4 over 3. But now remember that the graph has been shifted 3 units down, so I have to subtract a 3. So all I need to do here, guys, is to just write the equation like x minus 4 squared minus negative 4 over 3 minus 3. That's simply 13 over 3, negative 13 over 3. This is how you're supposed to write the equation of h of x. I really hope that, guys, the video helped you out. And please, guys, don't forget to share to your peers, like, comment, and subscribe. Thank you very much for your time, guys.